So good morning, welcome to Sakala Vidya YouTube channel. Okay, today we shall have the discussion on the mock test. The series will be continued, the mock test 3. So far we have completed 8 problems. So now other set of problems we shall discuss during this session. Right. So next we shall move to the ninth problem. So ninth problem. Okay. So let me write the question. All of you look at the screen. Good morning, Ravi Teja. Good morning, very good morning. So if n plus 2 C6 upon n minus 2 P2 equals to 11, then n satisfies the equation n satisfy the equation. First option is n square plus n minus 110 equals to 0. Second, n square plus 2n minus 80 equals to 0. Third one, n square plus 3n minus 108 equals to 0. Fourth one, n square plus 5n minus 84 equals to 0. Bunny Patel, welcome. Thanikonda Kiran, welcome. Okay. Now here see, first we need to simplify this one. We get a quadratic equation in terms of n. Next, the value of n also we can find out, which satisfies among the given quadratic equation we need to find out. So first, actually here you remember, see NC, for example NC6 is there, formula instead of n, so we have n plus 2, no problem. This we can write n into n minus 1, n minus 2, n minus 3 and n minus 4 and n minus 5 upon 6 factorial we can write. Similarly, for example, np2 is there. np2 means only two places are being filled with n without repetition. That can be done n into n minus 1. With the help of these two principles, we need to complete it. Tushant Thakur, welcome. Good morning, Ji. Good morning. Very good morning. So now this can be written like this. See, instead of n, you substitute n plus 2. You get n plus 2. Reduce 1 from this factor. You get n plus 1. Reduce 1. You get n. Reduce 1. N minus 1. Reduce 1. You get n minus 2. Total already 5. Next n minus 3. Upon 6 factorial. 6 factorial means 6 into 5 into 4 into 3 into 2 into 1 upon n minus 2 p2. n minus 2 p2 means n minus 2 and reduce 1. n minus 2 minus 1. n minus 3. So equals to 11. Yes, see, very interesting. So we have this n minus 2 into n minus 3. n minus 2 into n minus 3 gets cancelled. So now you do one thing. See, the remaining part write down. We have n plus 2 times, n plus 1 times and n times n minus 1 equals to this 11 multiplied by this one. 11 multiplied by this one means, so let us write the combinations. I will tell you. See, 5 2 ja 10 into 10 write down. into next we need actually 9. How do you get 9? From this 6 we can write 3 to ja. 3 into 3 9 right now. And 4 into 2 8 right now. Is completed now. Actually 4 factors. So as a product of 4 consecutive numbers we have written. That means either n plus 2 is equal to 11 or n plus 1 is equal to 10, n is equal to 9. So we get actually, if you compare on both sides, n is 9. So n value is determined. It has been determined. So now we need to check the options. Very simple way. Just check the constant. 110. 110 is not divisible by 9. So it is incorrect. 80. 80 is not divisible by 9. It's incorrect. So 108. So 108 is divisible by 9. You see, 9 1 ja 9. 18. 9 2 ja 18. Yes, 9 into 12. It is divisible. So third option is the right option. 9 satisfies the third equation. 84 is not divisible by 9. So it is discarded. So right, the third option is the right option. Okay, now the 10th question. 10th question. Are you ready, all of you? 10th question. If 4 raised to n plus 15n minus lambda is divisible by 9 for all n belongs to n, then the least positive integral value of lambda is first option 1, second option is 2, third option is 3, fourth option is 10. So for which least value of lambda the given expression is divisible by 9? The Sinu creations, welcome. See, if 4 to the power of n plus 15n minus lambda is divisible by 9, that means it is exactly divisible by 9. That means when you divide this expression by 9, it leaves a remainder 0. So for all values of n, natural numbers, the least value of the lambda we need to find out. So that means actually, let us say this value p of n, you say p of n equals to 4 raised to n plus 15n minus lambda. So now put n is equal to 1 because here n takes all the natural numbers. So if you put p of 1, so p of 1 is equal to 4 raised to 1 plus 15 multiplied by 1 minus lambda. This is equal to 4 plus 15 minus lambda. This is 19 minus lambda. So 19 minus lambda is divisible by 9. So that is the symbol 9 exactly divides 19 minus lambda. So now substitute the lambda values. So integral values. First you put lambda is equal to 1. What do you get? 19 minus lambda is equal to 19 minus 1 is equal to 18. Yes, 18 can be written as 9 into 2. So that means 18 is divisible by 9. So that means here lambda must be 1, least value. So 1 is the right option, first option. I hope you have understood this one. So already the mock test 1, mock test 2 has been completed. Those who are watching the first time this mock test 3, better you go for mock test 1 and mock test 2 also. The total syllabus will be covered. Based on this, it will be useful for your EAMCET examination also. It will be useful for your EAMCET examination, KVPY examination, all sort of board examinations of our country, global, from Kashmir to Kanyakumari, all the entrance, any state you can, these problems are very, very useful. So 11th problem. Yes. So first, all of you observe carefully on the screen. If one root of the equation, a minus b times x square plus ax plus 1 equals to 0, this is a quadratic equation, is double the, condition is given, double the other, and if a is real, that means a takes all the real values, then the greatest value of b is, greatest value of b we need to find out. See the first option 8 upon 4, second option is minus 8 upon 9, third option minus 9 upon 8, fourth option is 9 upon 8. So please, my dear children, once again go through the question. First question is very, very important. First you need to read the question very carefully. So you need to understand what is given and what need to be evaluated. That you need to keep in mind. See, one root of this quadratic equation is double. Double means twice, or the ratio between the roots are 1:2. Then a is real, the greatest value of b we need to find out. First let me speak out the condition, your solution. So if the roots of ax square plus bx plus c is equal to 0, a does not equal to 0, or in the ratio, then condition is, you remember the condition, or in the ratio m is to n, sorry I forgotten this ratio, m is to n, then that condition is mn b square equals to m plus n whole square into ac. First let us make use of this condition. This condition we need to make use of, we need to apply on this quadratic equation. So okay, let us now mn means actually here, see, double the other means if one root is alpha, other root is 2 alpha. So what is the ratio between them? M is to n is equal to alpha is to 2 alpha, alpha cancel, 1 is to 2. That means m is equal to 1 and n is equal to 2. Substitute here. You get 1 into 2, 2b square equal to 1 plus 2 is 3, 3 square is 9, 9 AC. Here b means actually here x coefficient substitute, a means x square coefficient, c means constant term. So let us substitute now. Let us substitute. Okay, so now we get like this, 2 times b square means here a square equal to 9 times a means x square coefficient, a minus b, c means 1. Okay, so now we get like this, 2a square equal to 9a minus 9b. Okay, bring this side. 2a square minus 9a plus 9b equals to 0. So now it is a quadratic equation in A, but according to the problem A is real. So that means since A is real means that implies discriminant D must be greater than or equal to 0. So D means b square minus 4ac, b square minus 4ac is greater than or equal to 0. In this b means minus 9 square, 4 times a means a square coefficient 2, constant is 9b is greater than or equal to 0. Let it be simplified. So 81 minus 72b greater than or equal to 0. Multiply with negative sign. So my dear children, always remember this step is very important. When you multiply the negative sign to the inequality reverses, changes. So 72b minus 81 is less than or equal to 0. So 72b less than or equal to 81. Now b is less than or equal to 81 by 72. So 9 9 ja, 9 8 ja. So therefore we get b is less than or equal to 9 upon 8. This 9 upon 8 will be maximum value. Therefore we can write b maximum equals to 9 upon 8. This is the answer. So fourth option is the right option. Shall I move to the next question? So once again, all of you check my work. Here in this question, actually we applied the two conditions. One condition is actually when the ratio is m is to n condition. After that, we applied discriminant condition. When the roots are real, the discriminant must be greater than or equal to 0. So using these two conditions, we just evaluated the value of maximum value of b. That's all. Now 12th question. So let's have a discussion on 12th question. 12th question. If the roots of x square plus px plus q equals to 0 or tan 30 degrees and tan 45 degrees, then 2 plus q minus p equals to first option 0, second option 1, third option 2, fourth option 3. So shall we try this question? The roots of x square plus px plus q is equal to 0 are tan 30 degrees and tan 45 degrees. Then 2 plus q minus p is equal to how much you need to find out. See, first of all, write down solution. Let here 30 degrees is equal to a and 45 degrees is equal to b. Sorry, this is okay, 15 degrees. Okay, so 15 degrees. A plus B equals to 30 plus 15 degrees is equal to 45 degrees. Okay, leave it now for a while. So now tan A and tan B are the roots of x square plus px plus q is equal to 0. So as we know the roots of the quadratic equation, we can find out sum of the roots and product of the roots. So that implies we can find out tan A plus tan B, sum of the roots. Tan A plus tan B equals to sum of the roots is equal to minus coefficient of x by x square coefficient. This will be minus p, and product of the roots tan A into tan B is equal to constant term by x square coefficient q. So but very important condition we derived. So we notice actually A plus B is equal to 45. From compound angles we have wonderful property. So if A plus B is equal to 45 degrees, so then we have 1 plus tan A multiplied by 1 plus tan B equals to 2. This is very important result. Please remember, it will be useful for your trigonometry chapter also. So let it be expanded now. So let us expand it. So 1 into 1, 1 plus tan B plus tan A multiplied by 1 and tan A multiplied by tan B. Tan A into 1 tan A plus tan A tan B equals to 2. Go back to the previous page. Tan A plus tan B is equal to minus P. Replace tan A tan B is equal to Q. So now instead of this minus P, we can replace instead of this Q. So replacing these values, 1 minus P plus Q is equal to 2. So what we need to find out? 2 plus Q minus P. 2 plus Q minus P. Add 1 on both sides. Add 1 on both sides. So on adding on 1 on both sides, 1 plus 1 is 2. 2 plus Q minus P equal to 2 plus 1, whose value is 3. This is the desired value. So answer is 3. You can check. So fourth option is the right option. So my dear children, so now just note in my work. So if you have any innovative method, you can suggest also, rather than this. I hope you might have followed this one. Right. So let us move to the next question. Don't waste the time. Let us directly switch over to the next problem. If f be a function such that f of 9 equals to 9, the value of f of x at 9 is 9, and f dash 9 equals to 3, then limit x tends to, x approaches to 9, root over f of x minus 3 minus root over x minus 3 is equal to first option is 9, second option is 3, third option is 1, fourth option is 2. Good morning Gayatri Bellam. Where are you from, Gayatri Bellam? Have you subscribed? First, see, my dear children, one instruction need to be given to you, all of you. Please subscribe and click the bell icon so that you will get the notifications. So to get the notifications, compulsory you need to subscribe and click the bell icon, and like and share also to encourage me to continue my classes. Right. So let us directly proceed to this problem now. So f be a function such that f of 9 is equal to 9, f dash 9 equal to 3. So there is a function which is satisfying the conditions f of 9, thank you, f of 9 is equal to 9 and f dash 9 is equal to 3, and we are asked to evaluate limit extends to 9 root over f of x minus 3 upon root x minus 3. So first let us substitute the limit here. What shall we get? Let us see now here. So this will be root f of 9 minus 3 upon root 9 minus 3. F of 9 is equal to 9, root 9 is 3, 3 minus 3 minus 3. Sorry, 3 minus 3 upon 3 minus 3. 0 by 0 form. This is indeterminate form. Indeterminate form. This is one of the indeterminate forms we obtained. So what shall we do now here? So whenever it is 0 by 0 or infinity by infinity, we can apply L'Hospital's rule. So that please remember, my dear students. See, we need to evaluate now limit x approaches to 9 root over f of x minus 3 upon root x minus 3. Apply L'Hospital's rule. L'Hospital's rule. Okay, let us apply L'Hospital's rule. Dilip messed up. Welcome, welcome Dilip. So see, the differentiation of the numerator separately, denominator separately. Derivative of root f of x is 1 by 2 root f of x into f of x derivative is f dash x minus 3 derivative 0 upon root x differentiation is 1 upon 2 root x minus 0. So limit here x tends to 9. So 0 leave it, no problem. 2 gets cancelled. So this can be written limit x tends to 9 f dash x upon root f of x multiplied by root x upon 1. Substitute the limit. This is f dash 9 upon root of f of 9 into root 9. Let us substitute. F dash 9 is equal to 3. F of 9 is equal to 9. Root 9 into root 9 is 3. Or root 9. This root 9 cancel. So we have 3. Answer is 3. Yes, B means second option is the right option. Virat Karthik Chintu. Good morning. Yes, B correct. B correct. Second option is the right option. Fourteenth question. Megha, welcome. Jaswant Shai. If 5, 4 minus 1, 1 multiplied by A equals to 1 minus 2, 1, 3. Then the trace of the matrix A is first option 14, second option 16, third option 13, fourth option 15. So this is called, actually matrix equation is given. Vijay Kumar, Shravani, how are you Shravani? Right. See, this is a matrix 2 by 2 matrix. 5, 4, minus 1, 1 multiplied by this also 2 by 2 matrix equals to 1, minus 2, 1 comma 3. Then the trace of the matrix A we need to find out. First we need to determine the A matrix. The trace we need to find out. So what is meant by the trace of a square matrix? Sum of the principal diagonal elements that we need to evaluate. So first solution write down. So let us consider P equals to 5, 4, minus 1, 1. Q equals to 1 minus 2, 1, 3. Now it becomes like this. P times A equals to Q. This is called matrix equation. Matrix equation. So we need to solve matrix equation. How to solve matrix equation means we need to operate P inverse on both sides. If you operate P inverse on both sides, P inverse of PA equal to P inverse multiplied by Q. So this can be written as a P inverse of P of A equals to P inverse into Q. Inverse matrix into P is I. So we get IA equal to P inverse Q. I is the identity matrix, so we get A equals to P inverse into Q. So with the help of this equation we can find out A matrix. My dear children, carefully observe. So that means we need to find out inverse of this matrix. So inverse of this matrix means, so first P is equal to what is given? 5, 4 and minus 1, 1. Let me explain. For example, A is equal to ABCD matrix. Its inverse, A inverse is given by 1 by determinant of this one, AD minus BC. So det of adjoint matrix. So interchange these two elements, DA, change the sign of these two elements, minus B minus C. So in the similar manner, let us find out P inverse. P inverse equals to 1 upon, this will be how much you will be getting? Okay, 1 minute. Sorry, actually I have taken wrong. This is 1. Sorry. This is 1. This is 1. Okay. This is 1. Right. So let us find out now. So now AD minus BC, 5 into 1, 5 minus 4 into interchange 1, 5, change the sign of the elements of this one. So minus 4 minus 1. Obviously it equals to, because 5 minus 4 is 1, 1 minus 4 minus 1, 5. Go back. So A is given by P inverse of Q. P inverse is 1 minus 4 minus 1, 5 multiplied by here Q. What are the elements of Q? 1 minus 2 and 1, 3. So we need principal diagonal elements. Principal diagonal elements means this element and this element we need to find out. So that means multiply this row. So 1 into 1, 1 minus 4 and multiply this row and this column. What do you get? 2 plus 15. So that is equal to principal diagonal elements minus 3 dash 17. So now the trace of A. Trace of A is equal to sum of the principal diagonal elements minus 3 plus 17. So answer is 14. 14 is the answer. 14 is the answer. So first option is the right option. First option is the right option. Next, 15th question. Yes, Dilip. Yes, Dilip. Meghana, absolutely correct. 15th question. If this bracket indicates or denotes the greatest integer, good morning Anjani Kumar Padma, less than or equal to the real number. So under consideration and subject to the condition, that means -1 less than or equal to x less than 0, 0 less than or equal to y less than 1, comma 1 less than or equal to x less than 2, then the value of determinant of det of integral part of x plus 1, integral part of y, integral part of z, first row, integral part of x, second row, integral part of y plus 1, this is integral part of z. So integral part of x, integral part of y, okay, integral part of z plus 1. Determinant value we need to find out. First option is 0, second option is 1, third option is -1, fourth option is 2. Anybody try this question? Subject to the conditions, actually we need to define the integral part of the real number using these conditions. So these conditions play important role. See here, with the help of this integral part of x, the x lies in between -1 to 0. What is the condition? Less than or equal to the real number. Less than means x must be less than 0, that is -1. So in between -1 to 0, that is integral part is -1. So in between 0 to 1, integral part of y is 0. In between 1 to 2, this is z. Integral part of z equals to 1. Substitute in this one now. Yes, let us see now. What do you get now? Required determinant is equal to, we can write det of integral part of x equals to -1 plus 1. Here integral part of y is 0, integral part of z is 1, integral part of x is -1, integral part of y is 0 plus 1, integral part of z is 1, integral part of x is -1, integral part of y is 0, integral part of z plus 1. Z plus 1 means 1 plus 1. So you get the matrix like this: minus 1 plus 1 0 0 1, minus 1 1 1, minus 1 0 2. So actually how to expand the determinant means the row or column which is consisting of more number of zeros given into the criteria priority. So expand by, so notation R1 means row 1. So that means here required the value of determinant is equal to 0 multiplied by the cofactor, or minus 0 multiplied by its cofactor, plus 1 multiplied by det of deleting this row, this column. So minus 1 1, minus 1 0. So you get 0 into something 0, minus 0 plus 1 multiplied by determinant of this one. So minus 1 into 0 0, minus into minus plus 1 and plus 1. So you get 0 plus 1 into 1. So obviously 1 is the answer. Yes. Second one, Dilip, you are correct. Second option is the right option. Option 2. Option 2 is the right option. Shanmuka Aditya, very good try. Very good try. Shall I move to next question? 16th question. So let's have a discussion on 16th one. If integral dx upon x square times x to the power of 4 plus 1 raised to 3 to the power of 4 equals to a times x to the power of 4 plus 1 upon x to the power of 4 raised to b plus constant, c is the constant of integration, then the value of a plus b equals to first option 1 upon 4, second option 3 upon 4, third option minus 3 upon 4, fourth option 0. Try this question. Try this question. Try this question. What is the answer? Look at the screen, all of you. So Nagasetti Jyoti. So generally this type of questions may be asked for even EAMCET, Andhra Pradesh or Telangana also. Difficult questions they are asking. Even it may be given for JEE Mains examination also. First we need to find out the definite integral of the given function, and it is being compared to this one. Compared to this one, we need to find out a value and b value. After that both add together, then that will be the answer. So first we need to find out integration of this one. Let us say this integral is I. So let us say, okay, solution. First let us say I equals to integral of 1 upon x square times x to the power of 4 plus 1 all to the power of 3 by 4 dx. Substitution method need to be applied here, but before that, from this bracket take x to the power of 4 common. That means x to the power of 4 plus 1 all to the power of 3 by 4. Take x to the power of 4 common. We have 1 plus 1 upon x to the power of 4 raised to 3 by 4. This 4 gets cancelled. It will be x cube into 1 plus 1 upon x to the power of 4 whole to the power of 3 by 4. So instead of this, we substitute this one. X square into x cube, that becomes like this now. So integral 1 upon x square into x cube, x to the power of 5 into 1 plus 1 upon x to the power of 4 whole to the power of 3 by 4 dx. Here one more thing you remember. Let us say t is equal to 1 plus 1 upon x to the power of 4. Why should you assume? Because this 1 by x to the power of 5 is the part of the derivative of 1 upon x to the power of 4. You are going to observe, you see. Differentiate dt by dx is equal to 1 differentiation 0, 1 upon x to the power of 4 is minus 4 upon x to the power of 5. So dt equals to minus 4 dx upon x to the power of 5. So that means multiply both numerator and denominator with 4. So this can be rewritten as like this. So minus 1 upon 4 times integral of 1 upon 1 plus 1 upon x to the power of 4 whole to the power of 3 by 4. This 1 upon 5 into dx we can write minus 4 dx x to the power of 5. See here, instead of this we can write dt, instead of this we can write t. So that means we get like this now. So minus 1 upon 4 integral 1 upon t to the power of 3 by 4 dt. This is minus 1 upon 4 integral t to the power of minus 3 by 4 dt. Simple first formula, x to the power of n, x to the power of n plus 1 by n plus 1. So this we can write minus 1 upon 4 t raised to minus 3 by 4 plus 1 upon minus 3 by 4 plus 1. So very interesting, minus 1 upon 4 into this will be t 1 upon 4 upon 1 upon 4. 1 upon 4, 1 upon 4 cancel. This will be I equals to minus of t stands for what? 1 plus x to the power of 4 whole to the power of 1 by 4 plus constant of integration. This can be rewritten as minus of 1 plus 1 x to the power of 4 whole to the power of 1 by, sorry, x to the power of 4, 1 minute, x to the power of 4 plus 1 x to the power of 4, 1 by 4 plus c. What is given? So given one is a times x to the power of 4 plus 1 x to the power of 4, b, this is instead of this one b given plus c. Comparing, what do you get? A stands for minus 1, b stands for 1 upon 4. We are asked a plus b. So minus 1 plus 1 upon 4, 4 LCM, minus 4 plus 1. So minus 3 upon 4 is desired answer. Third option is 3. Okay, let us move to the 17th question. Are you ready? 17th question. Let's have a discussion on yes, Meghana. Option 3. Integral 0 to 1 tan inverse 2x minus 1 upon 1 plus x minus x square dx equals to So first option is pi upon 4, second option is log 2 base e, third option is pi by 4 minus log 2 base e, fourth option is 0. So which is the right option? Anybody? Try yourself. So this problem should be done with the help of the properties of the definite integrals. So with the help of the properties of the definite integrals, this problem can be made very easy manner. So this problem can be cracked very easy manner. Okay, first, so let me try myself. Just follow. So let us say I equals to integral 0 to 1. I would like to write this one as like this, tan inverse of, okay, this I will write x minus of 1 minus x. So minus into minus plus 2x minus 1 only upon 1 plus x common, x times 1 minus x. So this appears to be like this, tan inverse of x minus y upon 1 plus xy. So we have the formula tan inverse x minus tan inverse y. So with the help of this formula, this can be written as a difference of the two functions. So now this I can be written as integral 0 to 1 tan inverse x minus tan inverse of 1 minus x. So now the integral can be applied to this function as well as this function. Split the integral now. So this can be written integral 0 to 1 tan inverse x and minus integral 0 to 1 tan inverse 1 minus x dx. Say equation 1. So let us do something now. It's my idea is, let us consider once again, say I1 is equal to, say this total, this integral is I1. Integral 0 to 1 tan inverse 1 minus x dx. Let us say this 1 minus x is equal to u. So du by dx equals to minus 1. So dx equals to minus du. Accordingly, we need to change the limits also. Lower limit x is 0, u will be 1. 1 minus 0, 1. Upper limit x is 1, so u will be 0. This is integral, we can write like this, 1 to 0 tan inverse u. This will be dx is minus du, minus common, this is du. If you interchange the limits, what will happen? The sign will change. So this we can write 0 to 1 tan inverse u du. Actually, in definite integral is independent of the variable. It does not depend upon u and du. Again, u can be replaced by x. So therefore, I1 is nothing but integral 0 to 1 tan inverse x dx. That means this is replaced by from 1 I equals to integral 0 to 1 tan inverse x dx minus this is replaced by integral 0 to 1 tan inverse x dx. Both are same, gets cancelled. So answer is 0. Desired value is 0. Desired value is 0. Fourth option is the right option. Fourth option is the right option. Okay, in the next class we shall continue and we shall complete the other 13 problems. 13 problems we shall complete in one session. Tomorrow we shall complete. Thank you. Bye.